Eunice Foote discovery. The year is 1856. The world is a cacophony of change. In London, the Great Stink is just 2 years away, a horrifying testament to unplanned industrial growth. In America, the tensions that will soon erupt into the Civil War are simmering, a nation tearing itself apart over its soul. Science, too, is in a state of flux. Darwin is still quietly refining his theory of evolution. Louis Pasteur is just beginning his work on germ theory, and the very concept of the Earth's climate is a vast, uncharted territory. Most scientists believed the planet's temperature was dictated by massive, unknowable forces: the sun's output, the Earth's distance from it, perhaps even the heat radiating from its molten core. The atmosphere was seen as a passive envelope, a simple mixture of gases that we breathed, but not as an active participant in regulating the planet's thermostat. It was in this world, a world of steam engines, telegraphs, and rigid social hierarchies, that a woman from Seneca Falls, New York, decided to ask a deceptively simple question: does the air around us actually do anything to the sun's heat? Her name was Eunice Newton Foote, and she wasn't just any woman. She was a physicist, an inventor, and a passionate advocate for women's rights. She had been one of the signatories of the 1848 Seneca Falls Convention, the first women's rights convention in history, her name appearing just below that of Elizabeth Cady Stanton. She was a thinker, a tinkerer, a person who saw the world not just as it was, but as a series of interconnected systems waiting to be understood. While her male contemporaries were building ever more complex apparatus to study the grand cosmos, Foote turned her attention to the invisible world right in front of her. Her laboratory wasn't a grand university hall. It was likely a sun-drenched room in her home. Her equipment was elegantly simple: 2 identical glass cylinders, 4 thermometers, and an air pump. With these humble tools, she was about to stumble upon a secret that the Earth had been keeping for millennia, a secret that would shape the future of our species. Her experiment was a model of scientific clarity. She took her 2 glass cylinders and placed a thermometer in each. Using her air pump, she removed the air from one cylinder, creating a partial vacuum, and compressed the air in the other, making it denser. She then placed both cylinders side by side in the bright sunlight, meticulously observing the thermometers. She noted that the cylinder with the compressed, denser air became significantly hotter than the one with the rarefied air. This was interesting, but it was just the first step. The real breakthrough was yet to come. Foote then decided to test not just the density of the air, but its composition. What if different gases behaved differently under the sun's rays? This is where her genius truly shines. She isolated different gases, including common air, oxygen, hydrogen, and something she called carbonic acid gas, what we now know as carbon dioxide, or CO2. She filled each cylinder with a different gas at the same pressure and repeated the process. She placed them in the sun and watched. And then she saw it. While all the cylinders warmed up, one of them did so dramatically. The thermometer in the cylinder filled with carbon dioxide climbed higher and faster than any of the others. It reached a scorching 125 degrees Fahrenheit, far hotter than the cylinder containing simple air. But the most crucial part of her discovery came next. After letting them heat up, she moved the cylinders into the shade to see how they cooled. The cylinders with air, oxygen, and hydrogen cooled relatively quickly, but the one with carbon dioxide held onto its heat with astonishing tenacity. It cooled far, far more slowly than the rest. Eunice Foote had just demonstrated, in a clear, repeatable experiment, the fundamental mechanism of the greenhouse effect. She had proven that a specific trace gas in the atmosphere could absorb and retain heat far more effectively than the air itself. She didn't use the term greenhouse effect, that would come later, but she understood the implications perfectly. In her paper titled Circumstances Affecting the Heat of the Sun's Rays, she wrote with astonishing prescience. The receiver containing the gas became much heated, and on being removed, it was many times as long in cooling. Then came the sentence that should have echoed through the halls of science for the next century. Extrapolating from her small glass cylinder to the entire planet, she concluded, an atmosphere of that gas would give to our Earth a high temperature. In 1856. Let that sink in. Before the world was powered by internal combustion engines, before the skies were filled with planes, before the Industrial Revolution had truly hit its stride, Eunice Newton Foote had identified the primary lever of planetary warming and issued a clear scientific warning. She had found Earth's fever. She had discovered that the composition of our atmosphere was not passive, but was, in fact, the key to a stable climate. She had handed the world a piece of knowledge so fundamental, so critical, that it could have altered the course of human history. Her discovery was a revolution, a monumental insight delivered with quiet confidence and backed by solid experimental data. The stage was set for a new era of climate science. But the world, it turned out, wasn't listening. The scientific establishment was about to receive her message, and through a combination of arrogance, ignorance, and deep-seated prejudice, they were going to bury it for over 150 years. Block 2. Science ignored her. On August 23, 1856, the intellectual elite of American science gathered in Albany, New York, for the 8th annual meeting of the American Association for the Advancement of Science, the AAAS. Imagine the scene. A hall filled with men in dark suits, bearded and serious, discussing the latest discoveries in geology, astronomy, and chemistry. It was the epicenter of scientific discourse in the nation, a place where reputations were made and the course of research was set. And on the agenda for that day was a paper titled Circumstances Affecting the Heat of the Sun's Rays. It was Eunice Foote's groundbreaking work. But when the time came for the paper to be presented, Eunice herself was nowhere to be seen at the podium. In her place stood a man, the esteemed Professor Joseph Henry of the Smithsonian Institution. In the rigid, male-dominated world of 19th century science, it was considered unseemly for a woman to present her own scientific findings to a public audience of men. Women could be assistants, illustrators, or computers performing tedious calculations, but the role of the public intellectual, the presenter of original research, was reserved for men. So Henry, one of the most respected scientists in America, read her paper aloud. We don't have a full transcript of his introduction, but reports suggest he prefaced the reading with a well-intentioned but deeply patronizing remark, stating that science was of no country and of no sex. The sphere of woman embraces not only the beautiful and the useful, but the true. It was a backhanded compliment, simultaneously acknowledging her work while reinforcing the idea that her presence in the scientific arena was an exception, a novelty. He read her clear, concise words describing her experiments, her data, and her staggering conclusion about carbon dioxide's effect on planetary temperature. And then, near total silence. The reaction from the scientific community was not one of excitement or vigorous debate. It was a collective shrug. The paper was mentioned briefly in the September 1856 issue of which summarized her findings and even praised her work, noting that the columns of the Scientific American have been graced with many productions from the pen of ladies, and that they were happy to say, in this instance, that the experiments were novel and the results highly valuable. A short abstract also appeared in other publications, but that was it. There was no follow-up, no attempt by other scientists to replicate her work, no integration of her findings into the broader understanding of atmospheric physics. Her paper, which should have been a bombshell, was treated as a minor curiosity, a piece of lady science, interesting perhaps, but not to be taken as seriously as the work done by the men in the room. Her paper was filed away, destined to gather dust in an archive, a forgotten footnote in a meeting filled with the important work of man. The injustice deepens just 3 years later. In 1859, a prominent Irish physicist named John Tyndall, working with far more sophisticated equipment, began publishing his own, more detailed research on the heat-absorptive properties of various gases. He independently confirmed that certain gases, including water vapor and carbon dioxide, were incredibly effective at trapping heat radiation. Tyndall's work was brilliant, comprehensive, and foundational to modern climate science. He is rightly celebrated for it. But for over a century, he was credited as the discoverer of the mechanism behind the greenhouse effect. Textbooks were written, histories were recorded, and Nobel Prizes were eventually awarded based on a lineage of climate science that began with Tyndall. Eunice Newton Foote's name was completely erased from the record. There is no evidence that Tyndall knew of Foote's work or plagiarized her. The real tragedy isn't one of individual theft, but of systemic erasure. The scientific establishment was simply not equipped to recognize, value, or build upon the work of a woman. Tyndall was a man, a professor with institutional backing, access to the best equipment, and a network of colleagues who read and cited his work. Foote was an amateur, a woman working from home, whose work was presented by proxy and then promptly forgotten. The system was designed for a John Tyndall to succeed and for a Eunice Foote to fail, regardless of the quality of her science. Her discovery was a seed planted in barren ground. It was an idea that arrived not just ahead of its time, but from a voice the world was conditioned to ignore. The cost of this dismissal was immeasurable. For the next 100 years, as the Industrial Revolution exploded and humanity began pumping unprecedented amounts of carbon dioxide into the atmosphere, the one piece of research that could have served as an early warning system lay dormant and unread. The world ignored her not because she was wrong, but because she was a woman. And that act of collective institutional blindness would have consequences that we are all living with today. Reclaiming her legacy. For more than 150 years, Eunice Newton Foote was a ghost. She was a name in the signatory list of the Seneca Falls Convention, a patent holder for an improved cooking stove, but her monumental contribution to planetary science had vanished without a trace. The history of climate science was written as a story of great men: Fourier, Tyndall, Arrhenius. Her chapter was ripped out before the book was even bound. It seemed destined to stay that way forever, a perfect, tragic example of the Matilda effect, the term coined to describe the systemic repression and denial of the contributions of female scientists. But history is not always a straight line. Sometimes, with enough digging, the lost pages can be found. And in 2010, a retired petroleum geologist and amateur historian named Raymond Sorensen was doing just that kind of digging. Sorensen wasn't looking for Foote. He was compiling a collection of historical science books. In an 1857 volume of, he stumbled upon a short summary of Professor Joseph Henry's presentation of Foote's work from the AAS meeting. He read the summary of her experiment, the glass cylinders, the thermometers, the different gases, and her stunning conclusion about carbon dioxide and a warming planet. Sorensen was floored. He knew the official history of climate science, and this was a decade before John Tyndall's famous lectures. He realized he had stumbled upon a forgotten origin story. He published his findings in a small trade publication, and slowly, like a signal from a distant star finally reaching Earth, the news began to spread. Researchers and historians, intrigued by Sorensen's discovery, located Foote's original 1856 paper. There it was, in black and white. The elegant experiment, the clear data, and the prophetic warning. The rediscovery of Eunice Newton Foote sent a shockwave through the climate science and history of science communities. It was a revelation that forced a fundamental rewriting of the timeline. Here was the true genesis of experimental climate science, and it had come from a woman's rights activist in upstate New York. It was both a triumphant moment of historical correction and a profoundly sad one. It highlighted the genius that had been overlooked and forced a painful reckoning with the question, what if? What if science had listened to her in 1856? What if her work had been celebrated, replicated, and built upon? Imagine a world where for over 160 years we had been aware of the fundamental relationship between carbon dioxide and the planet's temperature. The entire trajectory of the Industrial Revolution, of our energy consumption, of our urban planning, it all might have been different. We could have had a century-and-a-half head start on tackling the greatest existential challenge of our time. The cost of ignoring Eunice Foote wasn't just an injustice to her legacy, it was a potential setback for all of humanity. Reclaiming her legacy is about more than just adding a name to a textbook. It's a powerful lesson about the very nature of scientific progress. It shows us that groundbreaking ideas can come from anywhere and anyone, not just from established figures in prestigious institutions. Foote's story is a stark reminder that when we create barriers based on gender, race, or class, we are not just being unjust, we are being unintelligent. We are actively shrinking our pool of potential problem solvers. We are silencing the very voices that might hold the key to our survival. Her simple experiment stands as a testament to pure scientific curiosity, a beacon of ingenuity that cuts through the noise of complex theories and expensive equipment to reveal a fundamental truth. Today, Eunice Newton Foote is finally beginning to receive the recognition she was denied in her lifetime. There are symposiums held in her honor, articles written about her work, and a growing movement to ensure her name is placed firmly at the beginning of climate science history. Her story is a cautionary tale about the dangers of dogma and prejudice in science, but it is also a story of hope. It proves that truth, even when buried for centuries, can eventually come to light. Her legacy is not just about the discovery of the greenhouse effect. It's about the resilience of knowledge and the enduring power of a brilliant mind that saw the world with a clarity that her contemporaries simply could not handle. We must remember her not as a victim of history, but as the pioneer she was, the woman who found Earth's fever and gave us a warning that, after more than a century of silence, we are finally beginning to hear.